Hey everyone, I'm back. This is my third video in rational expressions. Last pair of videos I showed you guys how to multiply rational expressions. This video we're just going to add basically just one more step, which is dividing rational expressions. Now before we jump into this, let's just do a quick recap. Recall how you divide integer fractions. So let's say I've got 3 over 2 divided by 4/5. Okay. Now, if you're a student in my class, you've probably heard me tell you that division is a lie. Division doesn't actually exist. And the reason is because division is essentially multiplying by the reciprocal of a number. So when we divide by 4/5, that's the same as multiplying by 5/4. In fact, you could even go one step further and say that this is the definition of division. Dividing by a fraction is multiplying by the reciprocal of the fraction. Now, the one mistake I see students make with this, they often flip the wrong thing. You only flip the thing you're dividing by. The 3 over 2 is just chilling. That's just, it's being divided. It's cool. It's the 4/5 that we're dividing by that you actually need to flip. And then you just do your regular multiplication. 3 times 5 is 15, 2 times 4 is 8, and that doesn't reduce. Okay, so we're basically going to do this same step with rational division. But the challenge comes with our rational expressions with our restrictions. So if you remember from the last couple of videos, or if you know from multiplying rational expressions, anytime you got a variable in the denominator, you're going to end up with non-permissible values. And the challenge in this case is 5 is in the denominator here, right? But when we flip it, 4 ends up in the denominator. So you end up with a whole bunch of stuff that ends up in the denominator at some point in the question. And anytime it ends up in the denominator, you can't have 0. So let's jump into a challenging question. We've done some simple ones last time where I gave it to you already factored. Let's do one that is not factored at all. So let's do 4x squared minus 9 over 8x squared plus 6x minus 9. Divided by, let's do 16 minus 9x squared over 9x squared minus 24x plus 16. Okay, now before we can do anything with this, we're going to need to factor all the things, right? We've got a quadratic, 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 quadratic. So let's go through and factor. This one is a difference of squares, right? 4 is a perfect square, 9 is a perfect square. So you should know how to factor that in one step. 2x minus 3, 2x plus 3. Now this one underneath, 8, 9, not perfect squares. Okay, we're going to actually have to factor this with our long sort of trinomial factoring method. So you can factor this with whichever method you prefer. You could factor by decomposition. You could factor using a box method or area models. You could factor by guess and check. But the way I'm going to show you guys right now is something called fast factoring. And the reason I'm going to show you guys fast factoring is because it is fast. So I'm just going to write it again on the side here so we can factor. So 8 times 9 is negative 72. So we need to get a product of negative 72 and a sum of positive 6. So this is 6 times 12, and 6 times 12 have a difference of 6. So my two numbers are going to be 6 and 12. And what makes fast factoring a little bit different is your a value shows up in 3 places. So if you've never seen fast factoring before, this 8 appears here, here, and here. And then our two numbers are, we need to get positive 6. So the 12 needs to be positive and the 6 needs to be negative. And the way fast factoring works, this 8 underneath is always going to fully reduce into your 2 binomials above. So this one we can reduce by 4. So let's split this 8 into 4 times 2. And sure enough, this one can reduce by 2. So your final factored form is, so 8 divided by 4 is 2x, 12 divided by 4 is 3, 8 divided by 2 is 4x, and then 6 divided by 2 is negative 3. So there's your factored form. Okay, so let's fill that in over here. 2x plus 3 and 4x minus 3. Okay. So where were we? So now our right-hand side. Our right-hand side, this is a difference of squares again. 16 is square root is 4. 9 square root is 3x. So I guess I'll do my minus first and my plus second. Doesn't really matter. 1's minus, 1's plus. This one here looks like it's going to be like an ugly trinomial factoring again. But 16 is a perfect square, and 9 is a perfect square, which makes me think this might be perfect square trinomials, a perfect square factoring. So let's double check. So square root of 16 is 4, square root of 9 is 3. 3 times 4 is 12, and double 12 is 24. So this is indeed a perfect square trinomial. So this is going to be 3x and 4. And since this is minus, that's going to be minus, and it's squared. Okay, so now let's deal with our division. So when we are dividing by a fraction, we need to change this to multiplication by the reciprocal. So this 3x minus 4 squared ends up top. And this 4 minus 3x and 4 plus 3x ends up underneath. Now, in writing this, I'm noticing something else here. I've got a negative 3x coefficient. If you remember from my last video, this is a problem. It makes it a lot harder to recognize common factors if you've got if you don't have your x term first with a positive coefficient. So I'm actually going to redo this. When I'm flipping it, might as well do 2 steps at once. This positive thing, let's just rewrite it in order. The x term first, then the 4. And this term here, I want to factor out my negative sign. So I'm going to get a negative sign in front. And so essentially we're factoring out a negative 1. So negative 3x divided by negative 1 is positive 3x. And 4 divided by negative 1 is negative 4. Oh, and sure enough, there we go. 3x minus 4. We have a 3x minus 4 up top. So it's a good thing we did that. And our left-hand side is just chilling. All right, so let's just 2x minus 3, 2x plus 3 over 2x plus 3, 4x minus 3. Okay, now we need to be very careful when we are doing these expressions. We have variables in the denominator here. We have variables in the denominator here. After we flip, we have variables in the denominator here. So we're going to get restrictions for all of those different things. So before we move on, let's write down all of our restrictions so we don't forget any. So 2x plus 3. We have our non-permissible values. So our first factor, 2x plus 3 can't equal 0. Now we're going to need to do this a lot. Like in this question alone, we're going to do it, I don't know, 5 times or something. So we want to be able to do this really quickly. So if you imagine 2x plus 3 equals 0, not equal to 0, what we're going to need to do is we're going to need to take this positive 3, bring it to the other side, so it becomes negative 3, and then this 2 in front we're going to need to divide by. So it'd be really nice if we could just do this in one step. If you can imagine this positive 3 moving to the other side, becoming a negative 3, and then dividing by the 2, then we can jump right to this in one step. So let's try that with this one here. This negative 3 moves to the other side, becomes positive 3. Oh, sorry, not equal. So x not equal to positive 3, divide by coefficient of 4. This one here, we get positive 4. Let's scroll over. So x cannot equal to positive 4 over 3. And then down here, oh, this is the same thing again. You see, wasn't obvious in our, I erased it now. Wasn't obvious when it was reversed with the negative 3x over here. But since it's literally the same thing, you can see we already have that restriction. So our last one is going to be x cannot equal, this positive 4 becomes negative 4 on the other side, divided by 3. And so those are our restrictions or our non-permissible values. So we'll remember those and come back and put them back at the end. Okay, so now that we've done that, we ended up with non-permissible values from our denominator here, because we can't divide by 0. Non-permissible values from our denominator here, because we can't divide by zeros. And then after we flipped our fraction to its reciprocal, when we changed from division to multiplication, what was in our numerator now is in our denominator, which gave us another restriction. And last step, we just need to reduce what we can. So let's see. We've got a 2x plus 3 and a 2x plus 3. And I've got a 3x minus 4 and a 3x minus 4. So this 3x minus 4 reduces one of the 3x minus 4s up top. And I think that's it. 2x minus 3. Yeah, no 2x minus 3s. 3x minus 4s. No. Yeah, so we're done. So our final reduced expression, there's a negative sign here. So I'm going to put a negative sign in front, which makes the whole thing 2x minus 3 times 3x minus 4 over 4x minus 3, 3x plus 4, with restrictions. So let's just scroll over so we can copy these down. So where x is not equal to, let's do, okay, I'm going to run out of room. Okay, let me give myself a little bit more room and try again. So where x is not equal to, furthest to the left, I guess, let's do negative 3 over 2, and then negative 4 over 2, and then 3/4, and then 4/3. And so there is your final reduced expression with restrictions. Whew, that was a hard question.